In this video, let's try to solve the problem on your own. First, I'll read the question. If Z transform of un is 1 by 2 power n, show that Z transform of un is equal to 2z by 2z minus 1 from the definition. But in the question, they won't ask from the definition because you know that there is no formula. This is just a term, that is un is 1 by 2 power n. So, we have to find it by using basic definition. Try to solve it on your own and then I'll explain the answer. Yeah, if you see this, by definition, Z transform of un is summation n is equal to 0 to infinity un z power minus n. In the place of un, I have 1 by 2 the whole power n. Okay, so 2 power n, if it goes to the numerator, it will become 2 power minus n. Already we have z power minus n, so we have written 2z power minus n. Easy for us to expand the summation. Now put n is equal to 0. Anything power 0, 1. And then 2z power minus 1, 2z power minus 2 and so on. So this is 1 plus, now we can bring it down. 1 plus 1 by 2z plus 1 by 2z the whole square plus 1 by 2z the whole cube. This is nothing but a geometric series. And we know the summation is 1 by 1 minus r. Here r is 1 by 2z. Correct? So 1 by 1 minus 1 by 2z, and if you simplify, you will get the desired result. And if you see the second problem, again, find the Z transform of unit step function. They can give only unit step function because this is standard one. Unit step function is 1 when n is greater than or equal to 0 and 0 when n is less than 0. So we are going to find the Z transform for this function. Try to solve it on your own. What is the formula? Z transform of un is summation n is equal to 0 to infinity un z power minus n. So un is 1 z power minus n, and because 0 to infinity means for n greater than 0 value is 1. So perfect, it is 1. So 1 plus 1 by z plus 1 by z the whole square and so on. Again it's a geometric series with r 1 by z. So just applying the formula. 1 by 1 minus r, 1 by 1 minus 1 by z, simplifying we get this z by z minus 1. Okay, and we have this mini proof, that is z transform of un is u bar of z. If I know z transform of un, then z transform of n un is minus z d by dz of u bar of z. It's a derivative of it. We will be using this property also to find the desired result. Okay, so we have to prove it. To prove this, yeah, now it's visible. So I have to prove z transform of n un is minus z into d by dz of u bar of z. So I'll start with this because this is what I know, z transform of a function. So z transform of some function is summation n is equal to 0 to infinity, that function z power minus n. In the place of un, I have n un. Okay, so now what we are going to do is, we have z power minus n. So what we are going to do is add and subtract 1 to this power, z power plus 1, z power plus 1 minus 1, or you can write z by z, both are same. So z power plus 1, I have taken it to the front, this is z power 1, and z power minus 1, I have grouped it together. Okay, so why we have written like this? Because and one more thing, plus sign, now I am splitting it into minus because I want the derivative. Okay, so if you see this, minus n z power minus n minus 1, this is nothing but z transform of derivative of z power minus n. Okay, so derivative of d by dz of z power minus n is minus n z power minus n minus 1, same thing. So I have replaced this minus n z power minus n minus 1 as z d by dz of z power minus n. That is why we multiplied with z and divided by z, or we have added the power plus 1 minus 1. Plus 1 I am pushing it to the front, minus 1 I am bringing it back. Again plus means minus into minus, so 1 minus sign I have substituted in the front, and 1 I have kept it along with this so that I can replace it by d by dz of z power minus n. Okay, so this is nothing but d by dz of un z power minus n, and we are keeping this minus z as it is in the front, and this is nothing but u bar of z. Okay, so what is the formula? Summation n is equal to 0 to infinity un z power minus n. So we have taken the derivative to the other side, so this is nothing but u bar of z formula, general formula. So we have derived it. Okay, so this is a particular format in general. Okay, power n, this is very important. Z transform of n power k un is minus 1 power k z power k d power k by dz power k of u bar of z, where k is a positive integer. Okay, so for n un we have proved n power k means minus 1 power k z power k d power k by dz power k u bar of z. So I have to differentiate u bar of z these many times, k times, to get the desired result. This is yet another easy problem. Find the z transform of 1 by n plus 1. Again, basic definition, summation is equal to 0 to infinity 1 by n plus 1 z power minus n, and put n is equal to 0. So what we will get? 1 by 0 plus 1. So 1 by 1, z power 0 is 1. So first term is 1. So put n is equal to 1, 1 by 1 plus 1. So 1 by 2 z power minus 1, 1 by 3 z power minus 2, and so on. So this z, if you bring it down, 1 plus 1 by 2z plus 1 by 3z square plus 1 by 4z cube. This is what we have got. And what we are going to do is, we are going to take z common from the numerator. Why we have to do so? If I take z common from the numerator, since there is no term, I am multiplying and dividing it by z. So 1 by z. If you have a doubt, you just take it inside, z and z will get cancelled, I will get 1. So next term 1 by 2z square plus 1 by 3z cube plus and so on. It's like 3z power 3, 4z power 4. So why we are doing like this? Because we have, what is the corresponding series related to that we want to know. So log of 1 plus x, this is the series, plus and minus sign will come in alternate. Here all the values are plus. So this is what not we are going to apply. So we are going to use log of 1 minus x. 1 minus x is what? Everything is minus sign. Minus x square by 2 minus x cube by 3 minus x power 4 by 4. Okay, so but here everything is positive, so multiply with my minus sign. Minus of log 1 minus x, all positive values are there. So now I am going to relate this series to this. So in the place of x we have 1 by z, that's it. Everything else is the same. So minus log of 1 minus x was there, right? In the place of x we have 1 by z. So we have written this by this value. So this is, if I take LCM, z minus 1 by z, this is what we got it on the left hand side. So z transform of 1 by n plus 1 is z into log of z by z minus 1. Okay, so again I repeat, if you see this formula 1 by z, the place of 1 by z we have x, we are going to use this third formula, minus log of 1 minus x. So 1 by z is x, and then x square by 2. The place of x I have 1 by z, that's it. So in the series just replace by 1 by z. So left hand side of the series is minus log of, right hand side is the same, minus log of 1 minus 1 by z. So taking LCM, and then because of the minus sign, minus log of a by b, I can write it as log of b by a. So we are using log of z by z minus 1. So this is the solution for z transform of n plus 1. And if they ask problems like this, see this next problem, z transform 1 by n plus 1 into 1 by n plus 2. We don't have a direct problem and we cannot solve it. We cannot solve it directly, so we will be using partial fractions. So 1 by n plus 1 into n plus 2, we will resolve it into partial fractions, and then it will become 1 by n plus 1 minus 1 by n plus 2. Now z transform 1 by n plus 1 minus z transform 1 by n plus 2. Just now we derived this answer. Similarly we can solve for this. So basically here the idea is we are using partial fractions. In the next class we will see more problems. Thank you.